to do the easy one first, and then you can check. So, scale factor. This one we're going, and I'll put the direction here. We're going this way, so it's an enlargement, right? So SF for scale factor, and if the enlargement is, pick any two sides, okay, and you'll see that the ratios are the same. So let's pick again corresponding sides. This matches with this. This matches with this. Oops, sorry. That matches with this. This matches with this. So scale factor. It's the large one, right? Just make it simple. It's a big or a small. So this guy over the small one, which is 16. So the scale factor, and if you obviously 32 over 16 is 2. So the scale factor is 2. So notice that all of these, the increase, the factor, right, was by 2. So this was times 2. This was times 2, and that one was times 2. So the scale factor here was times 2. And literally that's it. So now we're going from this way, so the direction we're going from small, again, we're increasing, right? This is obvious, right? This matches with that. So the scale factor again, it's going to be 15 over 10, right? Big over small, and it's just 1.5. So the increase, so again, times 1.5. Now, should be pretty. Scale factor, now we're going the other way, we're going this way. So these two are corresponding, these two are corresponding, pick whichever one you want, and this is a reduction. The scale factor used, we're going to go small over big. Let's just pick this, the nice numbers, 6 over 8, simplified, 3 over 4. So 8, 2, right, we had a side that was 8, how did it become 6, times 3 over 4, we had a side that was 10, it is now 10, 7.5 times 3 over 4, so that was the scale factor. Big to small, so we're going this direction again. So scale factor is a reduction. I'll just put R for reduction, and it's in corresponding. Make sure you use the corresponding side, and it's small over big, so 4 over 5. Simplified. So again, try it out. 5 times 4 over 5. If you multiply 5 times 4 over 5, this and this simplifies to 1, and we get 4, which matches this. 15 times 4 over 5. This and this simplifies to 3, and 3 times 4 is 12. So you see, we have the right scale factor. And the scale factor using going from big to small. So we're going this direction. All right, and small. Okay, and we're going. So they're asking us to notice to see what we notice. So let's write the enlargement first. So let's do the enlargement, see what we get. So if it's an enlargement, we're going this way, right? It would be big over small, 9 over 6. And we're going to keep that as divided by 3, 3 over 2. Right, so it's times 3 over 2. Now, let's do the reduction. The reduction would be, if we use those two sides, would be small over big, 6 over 9. And what do we notice? They're the reciprocal, aren't they? Okay, so if you know an enlargement, obviously you know the reduction. Okay. Quadrilaterals, Q and P are similar with scale factor of the dilation that goes from P to Q. All right, so again, we're going both ways. We're going to go this way, and then we're going to go this way. So let's do the enlargement first. Enlargements, we're going to go from this to this, right? We're going this direction, getting bigger, so it'll be 5 over 4. All right, so the scale factor is 5 over 4. And the reduction, do we even have to do it? Because we noticed from the previous formula, it's the reciprocal, so the reduction would be 4 over 5. Okay, and you can always confirm, multiply 4 times 5 over 4, see if you get 5, and multiply 5 times 4 fifths, see if you get 4, going the other way. Seven, find the scale factor. Okay, and we're going, which direction? Going this way. This matches with this matches with this, and this matches with this. So can't use this side over here because I'm missing that. So either use the 16 and 40 or the 14 and 35. So we're going from small to big. It's an enlargement. And it's an enlargement, so let's pick this guy over this one. 35, so 14, and you can leave it as such. Okay. Let's see. All right, give me a second. 5. Very good. The next question, question 8. Find the scale factor. Okay. Is that the first page on? Page 1. God, I haven't made the right page. What did I just do? That one? Oh, yeah, this one. We're going that direction. There's an arrow right here. So what was the scale factor? Again, it's an enlargement. So we're going to be the big one over the small one. 15 over 10. And we can simplify that to 3 over 2. Okay, so the scale factor is 3 over 2 or 1.5. I don't remember giving you this page. Okay, but I'm going to do it anyway, just in case. Use a scale factor 3/4 to create a second rectangle. So this, if you use a scale factor 3/4, we're going to take that and multiply by 3/4. We're going to take the 12 and multiply by 3/4. So we're going to have a second rectangle. So because I know it's less than 1, the scale factor is less than 1, I'm going to have something that is smaller. 28 times 3/4 is 21. So this is going to be 21. 12 times 3/4 is 9. So after a scale factor of 3/4, the second rectangle becomes that one. Same thing here. Here's a triangle. Scale factor is greater than 1. So we know this triangle is going to be a little bit bigger, right? So it's an isosceles triangle. So let's multiply one. It's 10 times 1 1/4 or 1.25. So whichever one you use is fine. So this is going to be 12.5. If you multiply 15 times 1 1/4, you're going to get 18.75. This is 1875, and this is 1875. And I'm going to stop here because the rest is just repetitive, and I don't think I gave the other to you anyway. So the other sheet. All of it just, again, if you know, it's very repetitive. And I'll do a few of these. Scale drawing of a barn. So if you have a drawing and it says that it's 1/2 inch, please write your units. It makes life so much easier. 1/2 inch is 4 feet. If a flagpole is drawn, if the pole in the drawing measures 2.5 inches, how tall is the actual pole, right? Okay, so set your proportion 2.5 inches, or 2.5 if you want, and over x. Cross multiply, so if you cross multiply, I'm going to change that to a decimal, so I'm going to get 0.5x, and then we're going to multiply 4 times 2.5, and that's going to give us 10, right? I'm going to divide both sides by 0.5, and x equals 20. So the height of that pole in real life would be 20 feet. All right. So again, this whole thing is proportional. I didn't like this question too much, so I'm going to cross it out. Okay, if you did it, that's okay. I'm just going to skip it. 1 inch in the drawing. Okay, so let me just do it. So I think what this meant, because it was not very clear, 1 inch in the drawing, and there's where your labeling comes in handy, equals 4 inches in real life. And that was my issue with this question. So if the height of the chair is 42 inches, so they're saying the actual height of the chair, 42 inches in real life, how much is in the drawing? So there is your proportion. All right, so that wasn't that bad at all. Cross multiply 1 time. So if you cross multiply these two, right? 1 times 42 is 42. X times 4 is 4x. We're going to divide both sides by 4. So in the drawing, that chair will be how many inches? 10.5 inches. Okay. 3. A Titan rocket is 82 feet high. For a science project, Joe built a scale model of the rocket. How tall will be his model if the scale he used was 1 inch equals 5 feet? So 1 inch, for every 1 inch in his model, it represents 5 feet in real life. Again, inches on top, feet at the bottom, 82 over here, and this is x. Cross multiply, we get 82 equals 5x. Divide both sides by 5, and x equals, no idea, 16.4. So in his model, the rocket's going to be 60.4 inches. Scale model, again, another scale model. 1 inch, and again, 1 inch, 1 inch represents 2 2/7 feet in real life. So if the pants of that doll is 1 2/5 inches in the dollhouse, how long will the pants be in real life? Well, cross multiply. X times 1 is just x, and then we multiply 2 2/7. Okay, so I think the more tedious part is entering these numbers in the calculator. Times, again, 1 2/5, and we get 3 1/5 feet. 3 1/5 feet, 3.2 feet in real life. All right, so again, Abigail, blah, 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 decorates a house, blah, blah, dimension. So her house, in the drawing, let me draw her house, the dimensions of her house. It says in the drawing that this is 9 centimeters and 10 centimeters. Now, the real house, right, is much bigger, right? And we want it in feet. So what is it? How many feet is this? And how many feet is this in her real house? Well, you're going to have to do 2 proportions. First, you got to figure out what 9 centimeters is in feet, and then figure out what 10 centimeters is in feet. So the first proportion, and we have here 6 centimeters, right? 6 centimeters is 12 feet. So if I have 9 centimeters, how many feet would that be? Well, let's do that. So we got 6x equals 108. Divide both sides by 6, and we get 18. So this side over here of her house is 18 feet. Done. Now we got to figure the top part, the length. So again, let me set the proportion up. 6 feet equals 12 feet. And then we say 10 centimeters is how much in real life. Cross multiply again, we get 6x equals 120. Divide both sides by 6, and x equals 20. So this side of her house measures 20. Okay. You have to do 2. Big deal. Scale drawing, the distance between Salt Lake City and Arizona is 21 centimeters. If 7 centimeters, and let me write 7 centimeters equals 250 kilometers, how far apart is it in real life? So this is my scale that they give me, right? So now I measured the 2 cities. It came out to 21 centimeters. And this is my question. So what is 21 centimeters in real life? Well, x. Cross multiply, 7x. 250 times 21 is 5,250. Divide by 7, and x equals, no idea, 750 kilometers. So the 2 cities are 750 kilometers in real life apart. 8. In the morning, Sophie goes to church, blah, blah, blah. In the afternoon, she goes home. The map distance between school and home is 5 centimeters. If every 4 centimeters is 8 kilometers, how far is it? How far apart is school and home? School and home is 8 kilometers. So, right, hang on a second. The scale is 4 centimeters to 8 kilometers. So we want to know the distance on the map says that 5 centimeters is the distance between home and school. So in real life, how much would that be? Right, that's what I'm looking for. How many kilometers So x, 4x cross multiply, and cross multiply the other two, we get 40 divided by 4 divided by 4. So in real life, it's 10 kilometers. It's pretty far for a walk. I hope she's need to exercise. Andrew draws scales of his office. On his office drawing, it's 6 centimeters by. So again, this goes back to that picture. There's a drawing here. This measures 6 and this measures 7 centimeters. All right. So what is the actual in real life? What is the dimension of his office? All right. So what's the scale? It says that every 5 centimeters in his drawing represents 10 feet. So let's do this guy first. 6 centimeters represents how many feet in real life? Well, cross multiply, you get 5x equals 60, divide by 5, divide by 5, x equals 12. So this side measures 12 feet in real life. Let's go back and do the 7. So I'll do this guy here. So 7 centimeters in the drawing represents how many feet in real life. Again, cross multiply, 5x equals 70, divide by 5, divide by 5, x equals 14. This side of his office. And as a salesperson, blah, 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 on the map, the 2 cities are 50 centimeters apart. The map uses a scale. So every 2 centimeters, 2 centimeters equals 4 kilometers. All right, so on the map, it says that 2 cities are 50 centimeters apart. How many kilometers is that? That's the x. That's what we want to find. So cross multiply, 2 times x is 2x, 4 times 50 is 200, divide by 2, divide by 2, x equals 100 kilometers. So both cities are 100 kilometers apart. All right, 1 centimeter equals 5 kilometers. That's my scale. What would the map distance in centimeters be if the actual? So in actuality, so again, this goes a little back. So in real life, the distance between the 2 places is 14 kilometers. So how many centimeters would that be on the map? The x goes on top now, because that's the centimeters what I'm trying to find. Cross multiply. 1 times 14 is 14. 5 and x is 5. Divide by 5. Divide by 5. And we should get x equals 2.8. 2.8 centimeters would represent 14 kilometers. Geez. 12, again, so again, to give it a scale, I'm going to start writing it. 1 inch is 9 feet. Basketball court, again, one of those. So here's the basketball court. It's 94 feet here and 50 feet. So that's the actual dimension of the basketball court. So we want to know how much would it be in the drawing. So we're drawing the basketball court. Right? How do we change it? So 1 inch equals 9 feet. So let's do the 50 feet first. If I have 50 feet, how many inches would that be if I use this scale? So here's my x. 9x equals 50. Divide by 9. Divide by 9. And x equals, please be a nice decimal. And no, it's not. So we're going to call that 9 and 5/9 of an inch. I like that number better. If you wrote 5.55 or 5. If you round it, depending on what they rounded to, 5.56, that would have been fine. So this in the drawing, right, is, I'm going to leave it as a fraction, 9 and 5/9 of an inch. Now we got to do 94 feet. What would 94 feet be in your drawing? Well, what's that? 94 feet. Again, cross multiply. You get 94, and then 9 feet. 9 times x is 9x. Divide both sides by 9. Equals 10.44, or we can say 10 and 4/9 of an inch. And that would be what we use in your drawing. Okay. All right. Again, very repetitive, guys. All right, very repetitive. Again, in real life, it's 15 feet, right? The free throw line, and we want to know how many inches that would be on the drawing. 9x equals 15. Divide both sides by 9. X equals, let's see, 15 divided by 9, and no. So 1 2/3. Yeah, 1 2/3 is what I have.
And she's ready for it.
Okay.
In there for her.
Thank you.
Yep.
14 at the right, at scale drawing of a carpenter ant. Okay. Scale of drawing is 1 centimeter. 1 centimeter equals 2.5 millimeters. Find the actual length. Find the actual length. Find the actual length. Scale drawing. Okay, find the actual length. So 1 centimeter. So the head measures 1 centimeter. So the head in the drawing is 1 centimeter, which means that in real life, the head, and I'm going to just write here, head is 2.5 millimeters. Very tiny. Now, the thorax in the picture measures 1.3 centimeters. So 1.3 centimeters is what would represent the thorax? Right, that part of that. So cross multiply, and we get 2.5 times 1.3, and it would be 3.25 millimeters. Last part is the abdomen. The abdomen in the picture measures 1.6 So in the picture, the abdomen measures 1.6 over x, cross multiply, x equals 1.65 times 2.5. I don't have my glasses, so the abdomen is 4.125 millimeters. 15. Find the actual height of the mug. So again, half an inch. I'm going to use 0.5 over 3 centimeters. Okay. So in the picture, that mug is 4 inches tall. Right? In real life, well, how many centimeters will it be? That's what we're looking for. So we'll call this x. Cross multiply, we get 0.5x equals 12, divide both sides by 0.5, and x would be 24 centimeters. Okay. Pretty sure you're bored by this by now, hopefully. So I'm going to do, for the room, from the actual number is 5 centimeters. All right, very repetitive. I'm not going to do the last page, and I'll just stop right here. But you have to do it. Okay. And if you have any questions on question 17 to 22, actually, I have time. Sorry, I have time. I'll do it. I thought I had time. Scale here. What's the scale? 0.5 inches equals 50 miles. So on her map, it's 7 3/4. How many more miles? The map is 3 3/4. The scale of the map is, I think it should say inches, no? On her map, it's 7. So 7.75 inches. So in real life, how far is it? That's what I think the question should have said. So 0.5x multiply 50 times 7.75 equals 387.5, which we're going to divide by 0.5 x. Divide by 0.5, and it looks like it's 775 miles. Okay. Another scale model. He built a model of 7 inches to represent the actual height. But 7 inches represents 15 feet. What equation represents the relationship between the actual height in feet and the height of the model y? So the height of the model y would be y equals, which one's the y? The actual would be 7 over 15x. There we go. Actual, hang on a second. Actual is 15. Right? I'm calling that x, and this is y. Yep, y equals 7 over 15x. On the map, the scale has 2 centimeters equals 75 miles. They're 11 centimeters apart, so how far are they in real life? So again, if you write centimeters here and miles at the bottom, you know that this will go here, and this is what I'm missing. So 2x equals 75 times 11. We get 825. We're going to divide both sides by 2. And x equals 412.5 miles apart. So that's how far apart they are. Shoot. Floor plan, 3 centimeters. So again, 3 centimeters is 4.5 meters. The actual length of the living room is 5 centimeters on the drawing. How many meters is it in meters? There's my x. Cross multiply, 3x equals 4.5 times 5, which is 22.5. And divide both sides by 3, and x equals 7.5. So, in actuality, measure 7.5 meters. Again, 0.5 centimeters on the map is equal to 65 kilometers in real life. So China and New Sweden, I don't know why not New is it, if they're 4.5 centimeters apart on the map, how many kilometers are they apart in real life? Cross multiply, 0.5x, 65 times 4.5 equals 292.5. We're going to divide both sides by 0.5. And x equals 292.5 divided by 2. No, not divided by 2. What am I doing? 292.5 divided by 0.5. Okay, 585. So they're 585 kilometers apart. I don't think that's true though. All right, 2/3 of an inch, and again, is 8 feet in real life. So if you have something that's 2.5 inches apart on your drawing, how far apart are they in real life? X, so multiply 2/3 x equals 8 times 2.5, which gives you 20. And then we're going to divide both sides, or multiply, I should say, both sides by 3 over 2. Which is the same thing as divide by 2/3. So that would be 30. So in real life, it would be 30 feet. Last question. The blueprints of the house. Massive bedroom, so we have a bedroom on your drawing. It's 4 inches. This is 5.5 inches, right? Inches. So in real life, oh, again, same, right? What is this in feet? And what is this in feet? So let's do the 4 inches first. So I'm going to write 0.75 over 3 feet. Right, that's the scale. So if you have 4 inches on your map, how much would that be in real life? And that's what x. Cross multiply, we get 0.75x equals 12. Divide both sides by 0.5. 12 divided by 0. 12 divided by 0.75, and you get 16. So here x equals 16. So that means this side, which was 4 inches on the drawing, it's actually 16 feet. Part 1 is done. Second part, we do the 5.5. So that's my scale. So if I have 5.5 inches in the drawing, how many feet would be in real life? Again, cross multiply, 0.75x equals 5.5 times 3, which is 16.5. Now we're going to divide both sides by 0.75. And we get 22. So 5.5 inches in the drawing actually means 22 feet in real life. Okay, and that's your check understanding.